el ingeniero Marcel Laflamme. Marcel es ingeniero de minas de la Universidad Laval de Quebec, Canadá. Tiene una maestría en ingeniería de minas en la Universidad de Level con el tema de tesis de investigación sobre la relación entre seguridad y productividad en minería subterránea. Tiene un PhD, un doctorado en ingeniería de minas también en la Universidad de Level, Quebec, Canadá, con el tema de tesis de investigación sobre un sistema de optimización para operaciones subterráneas. En estos momentos, Marcel es profesor de la Universidad Laval de Quebec, Canadá. Trabaja en investigación y docencia enfocadas a minerías de tajo abierto, fraccionamiento de rocas sin explosivos, energías alternativas y eficiencia energética, así como salud y seguridad. También ha sido miembro y ha sido director regional de Recursos Naturales de Canadá, de la Canmet Mining. Ha tenido logros en la reducción de la huella de carbono y en el programa de investigación de energías alternativas, que implica un equipo de 50 personas ubicadas en 3 laboratorios regionales. También ha sido gerente del programa de investigación de Recursos Naturales de Canadá. Ha gestionado el programa de mecanización y automatización de una mina experimental. Las actividades de investigación fueron considerados como temas de productividad, seguridad, incluyendo ergonomía, trauma acústico y vibraciones. Recibamos por favor con un fuerte aplauso a Marcel Laflamme.
Thank you very much for inviting me here. I'm very happy to be here to present some of the work that we've done in the last few years related to noise and vibration. I had the idea to have my slides in French and English, present in French and have it translated in Spanish, but I decided not to mix all the languages. In fact, English is not my first language, so I'm sorry if I don't use the right words. I hope they will help me with the translation. So my presentation will be on the mine workers' exposure to noise and vibration in Quebec underground mines. In fact, I will cover, it's not only the mine workers' exposure, but it is also to present some work that we've done to help all the people working in the mining industry to have a better understanding when it comes to noise and vibration. So during my presentation, I will include, I think it should work. I was told that, yeah, there is a green point on the, I will introduce an informative document for the first part of my presentation. The informative document will give you much more information related to noise and vibration. I will also, after that, I will cover the mining equipment that we've studied, the data acquisition system that we've used to do the survey, some results for noise, handheld, hand, arm, and whole body vibration, some discussions at the end, and some of the discussions will cover an aspect that Tammy mentioned before for the seats, and then I will conclude my presentation. So in Quebec underground mines, there are more or less 5,000 workers who are exposed on a daily basis to noise and vibration, as it is in all the mining industry. In Canada, the Canada Labour Code stipulates that the employer must ensure that the levels of ventilation, lighting, temperature, humidity, sound, and vibration are in accordance with prescribed standards. But it does not define any limits. And when we look at the regulation in the 10 provinces and territories in Canada, there is none of them address vibratory exposure in their regulations. It means that in Canada, there is nothing, there are no standards that are adopted, there is no regulation related to vibration. Not the same thing for noise. Noise is well regulated, in each province. But for vibration, there is still a lot of work to do for the future. And when we consider that there are potential health problems related to vibration and noise, this is very important to be looked at in the future. 20 or 25 years ago, a number of claims related to noise has increased a lot and went up very rapidly over the years. Now we have the same, we're at the bottom of the curve for vibration compensation. And we feel that in the next few years, the number of compensations related to vibration will increase at the same level than what we have with noise. And that's going to be very expensive for the mining industry when we look at compensation. The reason why we've conducted our work is that noise and vibration of mining equipment is not always documented, and most of the time, and this was discussed with a few people before my presentation, it is not considered when choosing equipment. The reason is the cost associated with the technology very often. And in our project we have characterized noise and vibration in 8 different mines, and we have covered 28 mining equipment. First of all, I would like to cover the informative document that we have developed. The reason why this was developed, it was a request coming from the mining industry. We didn't decide to develop an informative document. It's really the mining industry in Quebec who asked us to develop that kind of informative document. And the idea was to draw a general picture of up-to-date information of mine workers' exposure to noise and vibration. And this document was written to reach not only the managers. The managers asked us to develop that tool, but was mainly for preventionists and occupational health and safety related personnel in mines. They need a better understanding on noise and vibration. Very often people talk about vibration. We know that a tool vibrates, but really, who knows what kind of vibration affects the people? Very often we hear that a manufacturer has developed a system that reduces the level of vibration by 50 or 60%. The problem is that the reduction of vibration that they get, the 50, 60% is true. But it's not for the vibrations that are damageable for the people. There is a range of vibration that is damageable, and that's very important to understand that if we want to talk and put in place a very efficient system to reduce vibration and noise. So the informative document was developed for preventionists, for them to have a better understanding, for managers and buyers to have as well a better understanding and take the right decisions. If we invest $25,000 additional to have a system that will reduce vibration, they have to understand why they invest that amount. And it's also there for the mine workers. Mine workers are, the informative document was really written in a way that all the people could read it quite easily, so the mine workers can understand how the vibration and noise could affect their health with time. So in the informative document, we have covered the 2 types of vibration, the whole body vibration that were discussed by Tammy in the previous presentation, as well as the hand harm vibration. This was mentioned, but I think by Tammy, but I think it's very important to repeat it. Whole body vibrations are transmitted by the seat and the floor of the equipment. And the epidemiological studies have demonstrated that back pain, disc herniation, degeneration in the spine could develop when exposed to vibration, and can be also the cause of fatigue, insomnia, stomach problems, headaches, and many others. As for hand harm vibration, they are transmitted by the hands of the worker, and we can see here a picture of a hand. It's not modified at all. It's a real problem. The Raynaud's disease, the white hand syndrome, is there, and this is probably one of the worst case, but this exists. So, and the problem related to vibration on the and harm on jack legs, for example, on portable rock drills, is amplified when the temperature is colder in the mines. So it is also the cause of carpal tunnel syndrome and tendonitis. In our case, Tammy mentioned that they used a standard. In our case, we decided to use the European directive to do all our work for this, for our project. In fact, as there is no regulation in Canada, in any provinces in Canada related to noise and vibration, we decided to use we decided to use the European standard. Hand harm vibration develops with time. We probably all know that. So on the x-axis, we have the daily exposure to hand harm vibration, the A8, or the exposure for an 8-hour period. And on the y-axis, the latency period to develop a problem related to vibration. So what this graph shows is, for example, if a miner is exposed to a level of vibration of 5 meters per square second for a period of a bit more than 4 years, there is 10% of the chance that he will develop a problem related to vibration, white hand syndrome. 30%, or 3 out of 10 miners, will develop a problem after less than 8 years, and goes up. And 5 meters per square second, if we look at the equipment, and we'll see that at the end of through the end of my presentation, is not, when we look at the equipment that are used in the mines, is not so high. Very often, we are in the area of 12, 13, 14, and even more than 20 meters per square second. If we think about the portable rock drill, the jack leg, it's more than 20 meters per square second, the level of vibration. So it affects very rapidly. You can see that it will affect very rapidly in less than 1 year, at least 10% of the workers exposed to vibration. In the informative document also, we have included the information related to data acquisition systems that are used by researchers and consultants. For researchers and consultants, what we need to have is the level of vibration and at what frequency the equipment vibrates. This is important for us to have that information if we want to bring solutions. As for the mine operators, what they need to know, at least, is the level of vibration to which their operators or their miners are exposed to, for them to either decide to remove them of certain tasks to reduce their time of exposure if the level of the vibration is too high, and have them do some other works. So the dosimeters are very simple equipment, and they measure directly the level of vibration, and they can be used very easily by the preventionist. And that's important for the preventionist to understand, and that's why we've put that in the informative document, where to locate. I don't know if I use the mouse, if that's going to work. Yeah, that works. So if we measure vibration on the hand, Tammy seems to be pissed off. So if we want to measure vibration on the hand of the worker, it is important to locate the sensors in the right way, because we have three axes, the X and the Y and the Z. As for the measurements on the floor and the measurement that we want to measure on the seat, the X, the Y, and the Z. So it is important to understand how to position the accelerometers, because there are, especially if we use dosimeters, the dosimeters will take into consideration weighting curves. And those weighting curves are built, I cannot move too fast. As for the hand arm vibration, we have the three axes. The weighting factor is adjusted according to the level, the frequency that we have with the equipment. So we can see that the frequency for the hand arm situation is in the area of 15 or 16 hertz. That's the level that is worst. As for the vibrations that are very low or very high, the risk associated with those vibrations is not as important. The weighting factor will bring them to zero. And that's why I mentioned at the beginning, it's important to know the frequency of the vibration to be able to adjust the real level of exposure. And if an equipment manufacturer tells you that it reduces the vibration, as I mentioned, by 50 or 60 or 70%, maybe it's in the area of frequency that is easier for them to reduce. But at the end, there is no real impact on the health of the people working with those pieces of equipment. In the informative document, we have also included the basic calculation methods for the daily exposure, the A8 to hand arm vibration, the daily exposure to whole body vibration, as well as the dose of whole body vibration. Why two measurements for whole body vibration? Any idea? Most of the time, the equipment that we use in mines produce impacts. The dose of whole body vibration will take into consideration the impacts produced by the equipment. So we can use the two parameters, either the A8 for the whole body vibration or the VDV. And in our project, we have measured both, and we will see later on during my presentation that for the mining equipment, it is very important to look at the VDV, as most of our mining equipment are exposed to produce impacts when they are used. This was well covered by Tammy before. The maximum recommended level for vibration for the hand horn doesn't work anymore. Yeah. So if the value, for example, for the hand horn vibration is lower than 2.5, the literature says that there is no risk. If it's higher than 2.5, we have to start thinking about taking actions to reduce the level of vibration. And if we are over the limit value, the 5 meter per square second, then according to the European directive, we should not use those pieces of equipment for hand harm. We have the same information for the whole body, the A8 and the VDV. In the informative document, we have not included spreadsheet tools to calculate workers' exposure to whole body and hand harm vibration, as that kind of information is readily available on the internet through those websites. So they can be downloaded and used very efficiently. Noise. I talked a lot about vibration. All the equipment, the mining equipment produce a lot of noise. But in the informative document, we didn't want to get into all the details on the basics related to noise. But we decided to bring some other aspects that are very important to consider. When we talk about noise, very often we think about a miner. When we think about a miner, for example, we think about his helmet, his boot, his belt, and naturally we think about hearing protectors. They are always there. Who knows exactly how they protect the people who are using them? Probably a lot of people, some others do not know. So this was already mentioned. We did look at the basics related to sonometry. There are many questions that can be asked or can be asked by the people to add noise, different noise levels, etc. We didn't want to enter into that, as I mentioned. All the information can be found easily on the web. But we wanted to cover the regulation. On the left side, there is the list of all the provinces and territories in Canada. In the middle, it's the maximum permitted exposure level for 8 hours. And on the right, it's the exposure rate. Not the exposure rate, the exchange rate. So in most of the Canadian provinces, we have most of the Canadian provinces, most of the Canadian provinces have adopted a maximum permitted exposure level of 85 dBA, with an exchange rate in most of the provinces of 3. So this means that a person can be exposed to a level of noise of 85 dBA for 8 hours. If the noise level increases to 88 dBA, we reduce by 2 the time of exposure. So if it's 88, that's going to be 4 hours of exposure maximum. 91 dBA, 2 hours, etc. The only 2 exceptions, Northwest Territories decided to use an exchange rate of 5 dBA, and the province of Quebec, the maximum permitted exposure level is 90 dBA with an exchange rate of 5. So you can see there is a big difference between the provinces in Canada, between, in fact, Quebec mainly, and all the other provinces. Is that going to change? Don't know. The reason why the Quebec province decided to keep that level of 90 dBA is that they realized that they would have to close their eyes, not look at the real situation in the mining industry if they had adopted the 85 dBA with an exchange rate of 3. So they decided to keep the level of 90, and eventually when the situation improves with equipment manufacturers, then they will adopt a new regulation. Hearing protection. We mentioned the equipment manufacturers gives NRR, the noise reduction rating for their hearing protectors. Either the earmuffs or the deformable earplugs. Should we reduce directly? Because what is important for the mining operators is to look at the level of noise in the workplace, and reduce the level of noise that is given by the NRR, noise reduction rating for earplugs and earmuffs. Should we reduce it directly? According to NIOSH, NIOSH conducted many studies, and NRR are developed, or the manufacturers get NRR in laboratories in perfect conditions. So NIOSH suggests that we subtract by 25% the level of reduction that is announced by the manufacturer to have the real reduction. So for earmuffs, we should use 0.75 times NRR. For the earplugs, we should use 50% of the NRR, and for the other plugs, we should use 30%. And as NRR the values of our NRR are in dBc, and we use dBA in the mining industry, we should reduce by another 7 dB to get the real value. So at the end, what if a sound level is in a working environment is 117 dBA with earmuffs NRR 29, the real value for the worker wearing those protectors is not 88 dBA. Really, it's 102 when we apply the factors of reduction. So that's important to consider when we measure the noise and when we supply protectors to our miners. And if a miner uses both systems, the earplugs as well as the earmuffs, it is recommended to add 5 dB of attenuation to the protection level offered by the most protective device. So we do not simply add the two values. What is the effect of removing hearing protectors during a shift? I will try this, that's going to be easier to explain. If the actual attenuation of a hearing protector is 30 dB, by removing the hearing protector for a short period of time, only 5 minutes, the real protection at the end will be only 19 dBA. If a miner removes his hearing protector for 1 hour, the real protection will be only 9 dBA. So when we select a hearing protector device, it's important not only to consider the level of attenuation that you can get, for example, the 30 dB, but also consider the fact that if a system is not comfortable, the miner will remove it from time to time. And at the end, the real protection will not be there. So it's preferable to have hearing protector of 20 dB that will be comfortable, that the miner will keep all the time, than having a hearing protector of 30 dB, but because that's not going to be comfortable, he will remove it at least for 1 hour during his shift. So if he keeps it all the time, we'll have 20 dB. The worst case, if he removes it for 5 minutes when the supervisors come to see him and the noise is still there, at least you will get almost 17 dBA of reduction, but compared to 9 if he removes it all the time. So those aspects are very important, and that's important to mention that, to inform the miners of that situation. Very often they do not care. They say, oh, well, it's only 5 minutes. You can see that the only 5 minutes has a great impact. In the informative document, we have also included the way to calculate the dose, the real the dose of exposure, the calculation of daily exposure for multiple tasks. I won't go into this this afternoon, but it's there in my presentation. Now, the heart of our study are the mining equipment study. We, as I mentioned, it's at the request of the mining industry that this work was done. Unfortunately, the time that we had to do our project, the mining industry wanted us to go fast. It's always the case. Time is important, and time is important as well because it costs a lot of money to conduct survey and to conduct research activities. So we had to, first step in our project, we had to define which equipment we would evaluate in all the underground mines in Quebec. So to do that, we have approached, first step that we've done is we have developed a questionnaire that was sent to all the mining companies to find out which pieces of equipment they were using. Not only say scoop trams or jacklegs or jumbo, but all the specifications on their equipment. we used that list. We compiled a complete list. It was a very, very extensive list. We had the number of equipment, all the specifications, etc. Now we had to reduce that list to a certain number of equipment to fit into the time that we had, the schedule that we had to deliver our project, and the budget that we had. To do that, we put in place a technical committee composed of miners, supervisors, engineers, hygienists, preventionists, etc. There were at least 15 people around the table. We looked at all the equipment that were in the list. We asked each member of the technical committee to define what they considered as the perceived severity for vibration or noise for all the pieces of equipment. One being very low, on a scale of 1 to 5, one being very low, 5 very important. The duration of exposure, again on a scale of 1 to 5, 1 being less than 15 minutes, 5 being more than 4 hours. The number of exposed workers, 1 being only 1 worker, 5 being most of the workers, and a priority, a discretionary parameter for each member of the technical committee. 0, no interest. That meant that the person on the committee was in a mine not using that piece of equipment. And 5, strong interest. When it came to scoop trams or jumbo, most of the mining equipment used them, so there was a great interest. So we've compiled all the information from the technical committee. We put that in a table. We put also a weighting factor on a scale of 1 to 5. We considered, the technical committee decided that severity was very important to be considered when selecting the equipment. So we put 4 there. The weighting factor for duration of exposure was 2. The number of people, we used a weighting factor of 2, and the priority a weighting factor of 1. So we compiled all the results, multiplied by the weighting factor, and we got, finally, our list of equipment to be surveyed. And all the members of the technical committee were very happy of the decision to look at those pieces of equipment in their minds. And this is the list of equipment that was not covered. For example, locomotive, bolters, wagon seats, etc. So those pieces of equipment were not covered in our study. Some of them were done on an individual basis. Some mining companies asked us to do some measurements for their own information. But in our study, they were not part of the evaluation. We also needed for our data acquisition system, we needed a robust, low-cost system. We knew that we would be in mines for a few months, and that we would measure vibrations on equipment that were, the environment would be very difficult. So we needed an equipment with multi-channel signal acquisition that would resist in a harsh environment, and that could be controlled remotely. Unfortunately, at the time that we decided to do our project, there was no such equipment on the market available. So we have developed our own system with 2 national instrument USB boards, lithium-ion battery, a mini computer with a solid-state hard disk, waterproof Pelican case that we can see here, and lab view system with 2 sampling rates for the hand arm and the whole body vibration. So you can see the system at the bottom here. Everything fits in a very small Pelican case and can be mounted on any piece of equipment without affecting the capacity of the operator to use his equipment. This table shows the results for the whole body vibration as well as noise. So here we have the daily exposure, the A8. And on this side of the, on this side of the table, we have the, the vibration dose for the VDV. I mentioned that we have the A8 and the VDV for the whole body vibration. And if we look at the results for the A8, so all the average level of vibration are in this column. And here we have the time after which action should be taken if a miner uses only that piece of equipment for during his work. So we can see that there are a certain number of equipment, and especially the MineCat, after 0.8 hours, we should take action because of the level of vibration produced by that piece of equipment. Same for the muck machine and the cable, 0.2 and 0.3 hours. As for the limit, we can see that most of the equipment can be used for more than 5 hours, 4 to 5, and even more than 8 hours with the, again, the A8. Only the mucking machine, the muck machine and the cable are at 0.9 hours and 1.5 hours. The maximum time that they should use it according to the European standard. But when we look at so the situation is not too bad when we look at the A8 results. But when we look at the VDV, as you can see for action, most of the equipment need action, and there are many more in the red with very low period of time before action should be taken. And again, 1, 2, 3, 4, and 5 equipment within 4 hours should we use those equipment. So this is very important to be considered. And if we look at the noise, the cable and the muck machine are really the worst equipment with 117 dBA. So even if by using hearing protection, that's very difficult to bring it to a level that would be acceptable according to the regulation. As for the hand arm vibration, same problem. Time for, we have the results here. Time for action, 0.1 hour for a jack leg, pneumatic rock drill, and 0.4 hours for the time limit. When we consider that many mines still use portable pneumatic rock drill, it's very important. And even with a system that would reduce by 60% the level of damageable vibration on a pneumatic rock drill, still the maximum time before we need to put in place action is 0.6 hours, but still we can work for 2.4 hours before exceeding the limit fixed by the European directive. And as for the noise, 117 dBA by the pneumatic rock drill, and the Kevo again, 115. And as for the other pieces of equipment, it's not too bad. So this graph just a bit repeat what I just mentioned about the pneumatic rock drill. As you can see, we cannot use the pneumatic rock drill for a long period of time before we get problems. And then for a short period of time, we still use it, but there is a risk, and then the level of risk gets very high. By using an anti-vibration rock drill, the anti-vibration handle on a rock drill, that is, I'm not sure if it's on the market right now. Parts Headquarters in Canada with Natural Resources Canada developed a system that reduces by 60% the level of damageable vibration, but still it's at the level of about 9 meters per square second. And the time before we need action is less than an hour, and a bit more, 2.4 hours for the limit. And just to repeat what Tammy, and to emphasize what Tammy mentioned about the seats. We've taken measurements on 6 loaders. On 4 of them, the level of vibration was not reduced at all by the attenuation seat. I should have put attenuation in brackets. In fact, they were increased for the reasons that were mentioned previously. The seats are not adapted to the equipment. They are not adapted to the operators. So we have to be very prudent when we decide to put on loaders attenuation seats. And it's really attenuation seat. Really, you have to take measurements to make sure that you get what you're paying for. Only 2 seats reduced the level of vibration, and those 2 seats were pneumatic seats. So in conclusion, the exposure to noise and vibration, there are many challenges. We're not at the end of the challenges. We don't have all the answers. We're looking for them, but I'm quite sure we will continue to work for a long period of time before we get there. But what we know for sure is that the number of claims increases dramatically. Every time a miner is on compensation, you have to pay for that person to be on compensation, and you have to hire a new person to work in your mine, and you have to train that person, you have to develop that person, and you have to pay at the end 2 times. We should be more aggressive and look at the possibility of adopting standards in Canada, and I imagine in all other countries. And that's important, and I think the industry is getting there. They understand the problem, and that's the reason why they gave us a mandate to look at all the equipment, that they work with us on technical committees to select the best pieces, all the equipment to be evaluated. They gave us access to their operations to look at the equipment. So this is something that we should continue to work on in the future. The action and sealing limit exposure are exceeded very rapidly for muck machine, Kevo, LHD, and handheld rock drills. This is very important to consider. And the suspension seats, be careful if you use them in your operations. Ask consultants or researchers to go there, take measurements, and just make sure that in the future you won't have more compensation than you expect. Just like to mention that this work was very well supported by the Quebec government, the federal government, the Canadian federal government, as well as the IRSST, the Health and Safety Research Institute in Quebec, as well as SORADEM, Society for Research and Development, that regroups all the mining companies in Quebec to prioritize and support research financially. Thank you very much, and if you have any questions.
Por favor, seguimos la misma metodología. Levantan la mano, se van a acercar con el micrófono. Ahí, por favor.
Buenas tardes, lo felicito por su exposición, es muy interesante para nosotros. Yo tenía una consulta por hacer y entiendo el tema de la problemática que hay en vibración, lo que explicó su compañera anteriormente y ahora lo que ustedes nos explican. En este caso mi pregunta es la siguiente, ¿hay temas para, digamos, minimizar el riesgo por vibración en los trabajadores, ¿no? Como son los temas administrativos, que es el tiempo, hay un tema de la capacitación para los operadores de maquinaria pesada para evitar el tema de los shock, que son los que más alteran los VDBs, estos límites que no deberían superarse en ningún momento, ¿no? También están viendo el tema de ingeniería para los controles de las maquinarias y también el tema de las condiciones de las vías donde se trabaja. La pregunta sería la siguiente, ¿cuál de estas, digamos, de estas medidas de prevención ha sido más efectiva para atenuar este riesgo en la minería subterránea en Quebec?
Very good question. I think there is no easy answer to that. For sure, I think we have to work on all those aspects. We have to look at the roads. We have to implement, to put in place protective equipment. We have to, as well, look at the tasks that the miners have to do and adjust the time, the maximum time that they are exposed to vibration and noise to a level that we will be able to meet the standards, the maximum recommended level of exposure. I cannot say more than that. I think we have to work on all the aspects at the same time. Not all at the same time, but I think we have to prioritize. But at the end, there is no easy answer to all that.
Otra pregunta, por favor. Levantan la mano.
Acá. Buenas tardes. Si tengo un sistema de adquisición de datos a nivel de vibración, yo necesito una línea base. ¿Cuánto tiempo necesito obtener la data y contra qué voy a comparar? ¿Cuál es la norma que me da la referencia para yo poder estar dentro de lo permitido?
I'm not sure if I understood correctly your question. Can you repeat that?
Si yo tengo un sistema de adquisición de datos, ¿sí? Yo necesito establecer una línea base para saber con cuánto estoy iniciando. ¿Cuánto tiempo necesito colectar esta data? Y después que yo colecto, ¿contra qué norma lo comparo para saber si estoy dentro de lo permisible?
much time it would take to, well, there are different standards that can be used. They were mentioned by Tammy a bit earlier. The best way, in our case, we decided to use the European directive. How much time it would take, if you take some measurements in your minds, then you know the baseline is already there because it's established by the standards. As for the equipment, it was decided, in our case, at least it was decided to go with the feeling of the operators as a first step, and then go in the field and take some measurements. And take measurements is not so long. If it's what you're looking for, take measurements in the fields. It can take a full day or a few days, a couple of weeks to be in the field. After that, you have to analyze the data to make sure that you apply the correct adjustment. The weighting factors are applied correctly to your data. So it's a question of a few weeks, depending on the number of equipment that you want to cover. If you want to do that on a short period of time, or if you want to extend to cover all the equipment, it can take a few weeks or a few months.
La última pregunta, por favor. Si alguien más tuviera una pregunta. Si no, por favor, un fuerte aplauso para Marcel Flaun, para despedirlo. Por el día de hoy estaríamos terminando el segundo día del seminario. Los invitamos el día de mañana a las 9 en punto para retomar el seminario internacional. Muchas gracias.